Okay. So we're going to go over lesson 7 real quick. And just briefly go over the answer and why we got that answer. So for question 3, it says, use the normal probability applet to find the combined area under the standard normal curve to the right of the z-score of 1.358 and to the left of negative 0.1358. And so our answer was 0.175, and on the app we just made sure that the outsides were blue and read the probability at the top because that's the area. And then number 4, which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? So it's 9, so it'll be skewed. And so to have the smaller deviation, we want the ones that are closest to the population's actual numbers. And so the distribution of individual observations will be skewed, so it can't be that. And so the distribution of the sample means will be the correct answer. Okay, now which of the following results implies that the spread in the sum of x decreases as the sample size increases? Now it's the law of large numbers because the central limit theorem talks about shape. This is talking about the formula itself with the samples. Exactly. So, use the following information to solve the next 4 problems. Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to her score? And that's just simply 1.045, which is found by 160 minus 150.8 divided by 8.8. What is the probability that a randomly selected student will score above this quantitative portion of the GRE? And so we just go and punch in on the applet 1.045 is the z-score and highlight everything to the right, and we get 0.148. For question 8, a sample of 5 students was taken for this GRE, and their scores are 160, 175, 163, 149, and 153. What's their z-score of this sample? So because we know it's a specific sample, we'll be using the new formula that we learned, which means that we have to find the means of the sample score, which is 160. Again, so that's nice because we take 160 minus 150.8 divided by, instead of the normal deviation, is the deviation divided by the square root of the number of samples, in this case 5. And that gives us an answer of 2.338. So for question 9, it says, what is the probability that 5 randomly selected units will have a mean score that is greater than the mean achieved by students in the previous problem? So, it's the same as in question 7. We just highlight everything to the right of the z-score of 2.338, and we get 0.0097. Now for question 10, it says, what is the shape of the sampling distribution of the random variable x, sum of x, which represents the sample mean of 81 students who are selected? Well, it's 81, which is more than 30, which we say is large enough to be normal, so it'll be an approximately normal shape. In question 11, what is the mean of the distribution of samples? Well, it says straight from the question that it was 3.5. And what is the standard deviation of distribution among the sample means? So this is among the sample means and not the normal population to standard deviation. So we take the standard deviation and divide that by the square root of the sample size, or 81. And so 0.7 divided by 9 is 0.078. For question 13, what is the probability that a mean GPA for 81 randomly selected BYU students will be less than 3.3? Now for this question, we have to again use our new formula of 3.3 minus 3.5 divided by our 0.078, and we get 0.005 when we enter in our newfound z-score onto the probability applet and only highlight the left side of the graph. For question 14, what is the probability that the mean GPA for these 81 randomly selected BYU students will be greater than 3.3? Now, there's 2 ways we can do this. We can either deselect the left highlighted portion of the graph and highlight the middle and right side, or we can simply subtract 0.005 from 1, and we get 0.995. Finally, for question 15, we approach this problem by first writing down the numerical information that they give us. And the population mean is 185, and the standard deviation is 26.7. The sample mean would be 177.6, and the sample number is 48. And using this information, we can use our newfound formula and say 177.6 subtracted by 185 divided by the standard deviation, which is then divided the standard deviation divided by the square root of 48. And that gives us our z-score. And we enter in our z-score and highlight the outer two portions of the graph, or we highlight the middle one and take that number of 1 minus that central area. Either way, we get an answer of 0.055. And that's all she wrote. Just for the record, Melissa was here, but was having computer problems and isn't able to complete the meeting. But she was here before we got all of this stuff figured out. Alright. So, next week, have fun in Hawaii.